A lot of my work focuses on looking at really large computational data sets of simulated hurricanes that we generate for different kinds of climates, whether that's a past climate or a climate that we might see in the year 2100, and trying to see within those large computer simulations how hurricanes are changing from one climate to another. A flood kind of similar to Sandy, maybe just a little bit lower than what Sandy was something that maybe would have happened only about once every 500 years prior to 1800. But now, mainly because of sea level rise, that kind of flood could happen once every 25 years. And as we move into the future, by about the middle of the century, it's the kind of flood that could happen about once every 5 years. A lot of the work that I've done looking at flooding from hurricanes has been focused in New York City, and what we look at there is how the hurricanes themselves might change as the planet warms, but also looking at how the sea level rise combines with changes in storms to cause flooding to change. A lot of our local assessments are underestimating the highest amounts of future sea level rise we could see, which really does translate to underestimating the risk that we could see in the future. There are some areas of the country where we just don't have any long-term sea level projections. So for example, in the US South, we didn't have any projections that go past the year 2100. And when we build something, we want it to last probably beyond the year 2100 in our coastal communities. So we need to be thinking more long-term. As scientists, when we're dealing with this every day, it's really important for us to then take those findings, like in my work related to sea level rise, and get that important information out there into the hands of people that can use it in their communities, and then start planning for how to make our coastal communities more resilient in the face of these hazards that we're facing.